Good morning.
Good morning, sir.
Good morning. In the last class, stopped at whether the given number is positive or negative. Now, this is the program for uh, whether the given number is either positive or negative. Okay, now we'll check it. Here, enter a number. Number is 10 here. Output is positive. The next one, again you will run with different test case. Enter a number -10. That is negative. No problem. Okay, that's not a problem. Okay, suppose if I can give the zero, enter a number, there is zero. Zero is negative number. Is
No,
zero
sir.
negative? No. That means that the test case has failure. Okay, the test case has failure. Okay, now how can we solve this problem? Okay, we'll check it. If the entered number is equal to zero, you have to write it system dot out dot println zero. Okay, this is zero. Whenever it is zero, this is also a return. Okay, this is also a return. Now coming to execute with input 0. What's the input here? 0. That is 0. Okay, suppose this is a very important concept. Suppose whenever you have to change your program, what is the new test case for the change? Not only that test case you can execute. What are the previous test cases also you have to execute? Because of once you can change the program, okay, that is not affected to previous test cases. What are the previous test cases? Negative number or positive number. Once you have to add the 0, one more code here. This is the code for n is equal to 0. Okay, your previous code, your previous test cases will not be affected. Will not be affected. Okay, that is now once again you have to check it. I will give the positive number. Okay, no problem. Once again you will check it with negative. Suppose -10, that is negative. All the problem has solved. Okay, your change cannot be affected previous test cases. For what test case you have to write once again the code. The code has written in your program for another new test case. The new test case cannot be affected old test cases. That's very important. Once you can insert the code for new test case, check that condition. Okay, check the test case. At the same time, we'll check it once again. Previous test cases. If previous test cases are not also affected means your new code has good code. The new code has inserted that code has affected the previous test cases means okay, that's not a good practice. Okay, that's not a good practice. Okay, now this is the program for either given number is even or sorry, either positive or negative or zero. Okay, either positive or negative or zero. Here, any what is the statement here I am following? Only the simple if. There is no else part here. Okay, if having the return, no need of else. Okay, if having the return, no need of else. Okay, here I have solved the problem here. Suppose here I will write it one more if n is less than 0, n is less than 0, you will get the same output. What is the disadvantage? In such a way, we will write it. In such a way, we will write it. What is the disadvantage? I will check the three conditions. N is equal to 0, n is greater than 0, n is less than 0. Suppose if there is no condition here, suppose you will give the n value 0, you will get the output 0, then return. Suppose you will give the n value positive value, this condition has failure, then come to if block is not executed. Next come to here, n is equal to 10, 10 is greater than 0, system.out.println positive or return. All are independent. All blocks are independent. Once the block has executed, that has to be terminated. Suppose you will give the negative number. Suppose minus 10. Minus 10 is equal to 0. False. Minus 10 is greater than 0. False. What is the need to once again? That is not a positive. That is not a 0. What kind of number it is? What kind of number it is?
Negative.
Negative. What is the need to check the n is less than 0?
No
By
need
default,
to
that is negative. No need to check. Okay, no need to check. Okay, this is no need to check. Suppose you write it, you should not get any change of output. But you have to write the optimized code. That's not a positive, that's not a negative mean, that's not a 0 means, that should be positive, that should be negative. Okay, that should be negative. Like this, you have to analyze test cases. You will get a lot of knowledge. You will get a lot of knowledge. The same thing, okay, how do you implement the Bayesian if else? How do you implement it with the help of if else means? Simply you have to replace this one else. Whenever you have the else here, no need of return. No need of return. No need of return. Okay, suppose for checking the n is equal to 0, you need the that is return, that if block. If your number is not greater than 0, not less than 0 means that is 0. Okay, you have the three options. You will write one if for one option, for remaining two options if else. Okay, for remaining two options if else. If having the else means no need of return in the if block. This if doesn't have the else. That's why here I used the return. Come here, if n is equal to 0, suppose I will give the n value 0, n is equal to 0, 0 is equal to 0, system.out.println 0 return. This block of statements are not executed. What I selected, if n is greater than 0, from there to system.out.println negative, no statement has executed. No statement has executed. Okay, because of whenever the input is n value is 0, that is 0, just return. The program has terminated. Your program has terminated. Next one comes to if n is equality positive, that is 10. 10 is equal to 0, that is false. Come outside of this if block, then 10 is greater than 0. That is true. System.out.println positive. If is executed means no need of return here. If is executed, else is not executed. After else, no statements are there. The program has terminated. After else, no statements are there. If is executed, else is not executed. If after else also having the statements, those statements are executed. But in this program, no statements after else. Okay, no statements after else means only if block has executed, else block will not be executed. Now come to minus 10. Minus 10 is equal to 0, false. Then come to minus 10 is greater than 0, false. Then come to else block system.out.println negative. If is skipped here, means finally what's the concept here? With different types of inputs, different blocks are skipped. Suppose the input is 0, these two blocks are skipped, not executed. If input is positive, this block has skipped, and also this block has skipped. If input is negative, these two blocks are skipped. That is the meaning of decision making. Okay, that is the meaning of decision making. Look here. Here, how many number of options here? Three options. Whether the given number is either positive, negative, or 0. Okay, three options. You need the two ifs here. Two ifs. One for check the 0, another one for positive and negative. If else is for positive, negative. If is simple, if is for only, that is the 0. How many types of possibilities here? Three possibilities means the three positives you have to solve. Okay, look here. The first one, I have used three ifs. Three simple ifs, there is no else. That is also valid. Ifs having the return means that is also valid. That is also optimized program. Okay, that is also optimized program. Okay, the next one, three possibilities. Two possibilities I will write. I have written here with the if else for positive and negative. For 0, I have written one more if. Okay, I have written one more if. That means the problem has solved with simple if and if else also. Okay, actually the concept of more than two options. Suppose the room have the more than two door through more than two doors. Already said that single door, that is simple if. Two doors, if else. More than two doors, that is else if ladder. You have to write it else if ladder also. Okay, now the same code I will keep it comments. Okay, and now I will write it if by using else if ladder n is equality 0. No need of returns all these things. System dot out dot printf. Printf also one of the function in system class. System dot out dot println, that is 0. Printf, that is 0. Next one, else if n is greater than 0, system dot out dot printf positive. That is positive. Next one, else system dot out dot println negative. Okay, same. Okay, here if n is equal to 0, how many conditions are checked here? With n is equal to 0, n is greater than 0. Three possibilities means how many conditions are required? Two conditions are required. By default, first door, always three doors are there. Three doors are for a room. Always one door has open means if the first door is closed, second door is closed means no need to check the third door. That should be open as per the conclusion.
Should be
Condition.
open.
That should be open. No need to check. What is the need to check? That is default. Here else is the default. Okay, else is the default. Same kind of output has generated. This is else if ladder. In the previous, how many conditions are there? This is the one condition. This is the second condition. Here, this is the one condition. This is the second condition. Whenever the first condition has satisfied, these two are not executed. The previous. Here, same thing. Whenever this condition has satisfied, if n is equal to 0, this block is executed. These two are not executed. These two are not executed. Whenever this condition has false, it will comes to skip this block, then comes to here. If n is greater than 0. If it is true, this if block is executed, else is not executed. Suppose here, if n is equality positive, that is 10, 10 is equal to 0, false means whenever it is false, it will comes to execute the next condition. 10 is greater than 0, that means only this statement has executed. If and else part is not executed, only else if is executed. Suppose here if the n value is negative, that is minus 10 is equal to 0, false. This condition is false, then this block is skipped. Then comes to this condition, if 10 minus 10 is greater than 0, that is false. This block is also skipped. Then else block has executed. The same process, if n is equal to 0 here, n is equal to minus 10 is equal to 0, false. That means if is not executed, if block is not executed, then come to else if minus 10 is greater than 0, that is also false. This block is not executed. If it is not a 0, okay, if it is not a 0, if it is not a positive means by default, okay, this is a negative. Both implementations are same. This is the implementation for LCF ladder without using LCF ladder. Without using LCF ladder, above is the, suppose in interview, the interviewer can ask, please write the equivalent code of LCF ladder without using LCF ladder. Without using LCF ladder, I have the three conditions, I have the three possibilities. Okay, without using LCF ladder, how can you implement the LCF ladder? Means optimized LCF ladder. The above said this is the optimized LCF ladder. Okay, suppose the same thing you have to write it. Okay, you have to observe what is the difference here. Here instead of else, I will write once again n is less than 0. Okay, n is less than 0. Check it. What is the why it is not optimized? I will explain. Suppose if n is not equal to, suppose if the n value is minus 10. Minus 10 is equal to 0, false. That means this if block is not executed. Minus 10 is greater than 0, this if block is not executed. What is the need to check the condition here? If n is less than 0, that's not a 0, that's not a positive. What is the need to check? That is the disadvantage. No need to check. This is also implementation. The LCF ladder we are using simple ifs, having the returns. Okay, having the returns here, I will write the return also. Having the returns that is equivalent to LCF ladder. But what is the disadvantage? For all possibilities, you will write the condition. For all possibilities, you will write the condition. That is a problem. Okay, if it is not a 0, if it is not a positive, if it is not a positive means by default that is negative. By default that is negative. What is the need to check? Okay, here we will write the condition means this is disadvantage. Okay, this is the disadvantage. In the previous, here there is no condition. This is the else block. Okay, suppose now we will write the 10 possibilities. Okay, you will have the 10 possibilities. Listen carefully. Okay, how do you implement 10 possibilities? How do you implement 10 possibilities? You will write 9 ifs. The last if having the else. Okay, here we have the three possibilities means how many ifs are there? This is the first if, this is the second if. Second if itself having the else block. If you have the 10 possibilities, how many ifs are required? 9 ifs are required. The default is the else. Yes or no? Yes or no?
Yes, sir.
Yes. That is, what is the, in such a way we will write it. Suppose you have the 10 possibilities. How many conditions are required in such a way we will write it? 10
9.
conditions you will write. No, no, in the second implementation, what I selected here.
Okay,
What
sir.
I said, how many conditions are required? 10 conditions are required. Here, how many conditions are required in the LC ladder? 9 conditions are required. If you have the 10 possibilities. In the first implementation, how many conditions are required here? 9 conditions are required. That means this is equivalent to this one, but this is also equivalent to this one. This is also equivalent to LCF ladder, but what's the problem? Here we should require the 10 conditions. It is optimized. What is the need of 10 condition? You have to execute the 10th condition also means you need some time. You need some time. You have to avoid such type of with the help of else if ladder. Ifs having the returns, 10 possibilities means you have the 10 ifs, last if having the else. That is also equivalent to else if ladder. Okay, that is also equivalent to else if ladder. You have more than one option. If else, more than two options. Okay, by using simple if else. Okay, if you have more than three options means suppose four options, three are ifs, the fourth one is the else. The last if having the else. That's it. Understand? Understand all of you?
Yes, sir.
This is about your complete if, simple if and else if ladder. Okay, simple if and suppose the same program I don't want to process the zero. I don't want to process the zero. I have to process either positive or negative. If I can enter by mistake, if I can enter the value 0, okay, it cannot be processed. Suppose even or odd, you will write it even or odd. 0 is not even, 0 is not odd. What is the need to process? What is the need to process? Means whenever if it is 0, you have decided, no need to check that n value mod division 2 is equal to 0 like this. It is optimized. Then you can write such kind of code with the help of nested if else. By using nested if else. All the programs are written here, no problem. Everything has written here. All are in comments. Now I will write it. If n is equal to 0, I don't want to process. Simply system dot out dot println you entered 0. You entered 0. In the else block, nesting. Okay, in the else block, I will write the nesting. Here I will write it if n modulo division 2 is equal to 0, system dot out dot println even. Otherwise, system dot out dot println out. Okay, this is the program. This is called as a nesting. Else having the if else. Okay, else having the if else. In the theory part also I said this. I explained this. Here I will show the programmatically. Okay, in the material also same. What I said in the material also having that concept. The same here I have to implement. I have to show here once again. If n is equal to 0, system.out.println you entered 0. If it is not a 0, then comes to else what? If n mod division 2 is equal to 0, that is even. Otherwise, that is odd. Here, what's the nesting? This else block having the if and else. If having the if or else also having the if is called as a nesting. It is called as nesting. Now we'll run this program. enter a number here 0, you entered 0. If once you know that is 0, I think you don't need to process. You don't need to process that is even or odd. That means if n is equal to 0, else is not executed. What is in the else here I return even or odd logic. Okay, even or odd logic. Now I'll write it. Now once again I will add. Okay, now even number 12, I'll get even. N is not equal to 0, then come to else block. If n mod division 2 is equal to 0, system.out.println. Okay, system.out.println odd. Means if n is equal to, suppose I will give the odd number. Odd is 13. Get the odd. You will get the odd. By using nesting also you have to do it. Okay, this is called as a nested if else. Okay, suppose I want to process the input in between 1 to 100. Suppose I will enter the student age. The student age is in between 18 and 25. Suppose engineering student means 18 to 22. Instead of that, if I can give less than 18 or greater than 22, okay, greater than 22, I don't want to process. I don't want to consider him or her. I don't consider them. Okay, I don't consider them. If their age is in between 18 and 22, then only I will consider. If whatever that consideration here, that is called as nesting. For all numbers, for all ages, I don't consider. What is the range of ages here? I have to consider 18 to 22. If age is greater than or equal to 18 and age is less than or equal to 22, then I will process those students. Then I will process they are the students and whatever the benefits I will give in that block. If having the if. Okay, if having the if, that is called as a nesting concept. Okay, that is called as nesting. There is no limitation. If having the if, that if also having the if, that if also having the if, that if is also having the if. There is no limit for nesting. Okay, there is no limit for nesting. Okay, understand what is the all the if statements here? All the if statements with a single program. Okay, I shown all. Okay, do you want this one? Hello,
Yes, sir.
you want this one? Do you want this one? This
Yes, sir.
program? This program? Okay,
Yes, sir.
okay. I will copy and send to you. Okay, I will take one more file. Select the new class. Having the public with public static void main. Class name is already I have the main one. Okay, this is a skeleton of the program. Here I didn't type anything. Automatically it will use. That is the advantage of. Okay, here you need to read the values. Which package? Which package is required to read the values? The last class I said that import
UDL.
util, not util, util. Okay, import java dot util dot store. Otherwise, you will write simple scanner also. Util dot which class you have to access, you will write it, no problem. Okay, java dot util dot scanner. Okay, java dot util dot scanner. Okay, next one. Here, create the object for scanner class. Scanner s is equal to new scanner of system dot in. New scanner system dot in. Scanner s is equal to new scanner system dot in. Next, system dot out dot println enter a number. Now in this program, I will explain using the switch case. Okay, using the switch case, system.out.println enter a number. Here I need a one variable, that is int n. In Java, wherever you have to declare, no problem. In the middle, wherever you have to declare the variables, that's not a problem in Java. But in C language, once you can start the brace follows the variable declaration. But in Java, wherever you have to declare int n. Next one, read the n value. Okay, that is I will how can I read the n value? N is equal to what is the statement? How do you get the n value? From the keyboard. Always scanner object is there. What is the method to access to use for read the method, read the integer? The last program have the statement scanner object dot, which is a scanner object here, s dot, which type of integer? Okay, s dot integer. Next int. Case dot next int. Read the next integer value. Now come to switch. Suppose switch. Okay, here I will take the one more two variables int a comma b. Okay, here write the system dot out dot print for menu. Okay, menu having the items. System dot out dot printf one for printf one for add, one for add. Next, two for sub, three for mark. You will go to next line. The menu has shown in line by line. Three for sub. Next one slash n. Fourth one. Fourth option is div backslash n. Fifth option is mod div. Modulo division. Mod div backslash n. Okay, from this is the menu. From this menu, I will select any one of the option. If that option is okay, here I will read it n value. After this, I will read the n value. Enter our choice. After menu, I will read enter your choice. This is a choice program. Enter your choice. Next, read the n value. N is equal to s dot next int. S dot next int, that is switch n. Okay, here switch, this is the expression. What's the type of this expression? What I substitute there in the expression place? N. What's the type of that expression? Either integer constant, character constant, or string constant. Here n is an integer constant, no problem. Switch means exact selection. Okay, switch means exact selection. Not the, it will not check the in the range of values. Suppose if it is n is equal to 1 here, case 1 has selected. Okay, case 1 has selected. If n is equal to 2, case 2 has selected. That is the exact selection, equality comparison. Okay, equality comparison. Now, come to here is the first case 1. Okay, case 1. Now write it. A is equal to, read the first value, system dot. Okay, here I will read two values. Enter choice after. Before that, I will take the two values. System dot out dot println. Enter A and B. Enter A and B. Okay, now we'll read the A is equal to A is equal to S dot next int. A is equal to S dot next int. B is equal to, okay, read the B value next int. Okay, here enter AB values. Enter AB values. A has read by next int. B has read by next int. Two times I call the next int. Once again also I call for choice. Okay, don't take this one as a n. Take it as ch. Okay, this is also ch for choice. This is also ch. Okay, whenever case 1, that is ch is equal to 1, case 1 has selected. Here I will write it system dot out dot println a plus b. A plus b break. Okay, a plus b break. Next one. Okay, I will copy all the cases I will copy here. This is the case 2. This is a minus b. This is case 3, a star b. Case 4, a divided by b. Case 5, all the menu items here. A modulo division. B. Instead of these 5 cases, if any other case you can enter, that is default. That is default. That is default. There we will write it system dot out dot println invalid choice. Invalid choice. Okay, this is the program. Okay, this is the program. First, the program will start from here. System dot out dot println enter a comma b. Read the a value and b value with the help of scanner class and next method, next int method. Then system dot out dot println. This is the menu. Okay, this is the menu. From that menu, you have to choose any one of the option. From that menu, you have to choose any one of the option. That option has read by s dot next int. That is stored into a ch. Then switch ch. What is the option you enter? Okay, that option has selected. Okay, one of the case has selected. Okay, now I can execute this program. main one. We enter AB values. Now we'll give the tenant. Okay, tenant 20. Here this is the menu. What are the options in the menu? What are the items in the menu? Add, sub, mul, div, and mod div. Okay, enter our choice. Suppose I will give the one. Which case has selected? Here, what is the CH value? Whenever I will give the n, say 1 here, that is copied into CH. S dot next means that is copied into CH. Switch CH. What is the CH value? 1. Which case has selected? Case 1 has selected. How it is selected?
By using equality condition.
Equality relation. Okay, by using equality relation. Okay, now enter our choice is 1 here. Okay, where output is equal to 30. Okay, output is equal to 30. Okay, now once again you have to check the second one. If there is no break here, okay, I will tell you later what is the without break, what is the problem. Now enter AB values 10. Don't give the spaces here. You will enter. Okay, that is enter our choice. Suppose minus sorry 2. Output is equal to minus 10. Output is equal to minus 10. What is the CH value here? 2. Which case has selected? This case has selected. Okay, this case has selected. Next one. Once again, I will run the program. Enter AB values 10 and 20. Okay, what is your choice? 3. Output is equal to 10 into 20 is equal to 200. That is, which case has selected? Case 3 has selected because of choice is 3. Then I will give the option 4. Okay, inputs are 10 and 20. Okay, option 4. Output is equal to 0. 10 divided by 20 means both are integers. The value is 0. Quotient is 0. Next one, modular division. Now what is the output? If I can give the 5 here, modular division, 10 modular division 20. What is the output?
10.
10. If numerator is less than denominator, numerator is the remainder. Okay, quotient is 0 means dividend is the remainder. Quotient is the 0 means dividend is the remainder. Because of division into quotient is multiplied, these two are multiplied, that value is subtracted from the dividend. If quotient is 0, whatever the divisor, okay, the product is also 0. Dividend minus 0 is equal to dividend. Which is the dividend? Numerator is the dividend. Numerator is the dividend. Next one. Now I will give the invalid choice. You have to check that one also because of you have the code 10 and 20. Now I will give the 6 invalid choice. Now all the cases are executed at the same time default is also executed. You should have the awareness. You should have the awareness. What kind of input I can give, what block has executed, you have the awareness. Okay, you have the awareness. That is the meaning of default. Default means no case has selected. By default, okay, what is the case? Okay, what is the case selected here? That is called as default. In LC Flatter, which is the default? In LC Flatter, which is the default?
Last condition.
Not last condition, LCs. Suppose you have 10 condition, 10 possibilities means you will write only 9 conditions. The 10th one is default. Which is the 10th one? Else is the default. 10 doors are there. 9 doors are first 9 doors are closed means 10th door no need to check. By default that is open. By default that is open. That is default there in LC Flatter. In switch case the name itself is the default. Okay, the name itself is the default. Suppose if there is no break here, what will happens? You will find out what is the advantage of break here. 10 and 20. Option is 1. Whenever I selected the choice, that is the first one from the first menu item, case 1 has selected, okay, we'll get addition and also subtraction. Case 1, not only case 1, case 2 is also selected. What is the reason means between these two there is no break. Between these two, that means addition going to subtraction free. Addition going to subtraction free. Multiplication going to division free. Ala. Okay, understand. What is the output? Come to here. 30. 10 plus 20 is equal to 30. 10 minus 20 is equal to minus 10. Okay, that is offer. Suppose you can buy one thing, you will get one thing, another one. You have to select one menu item from the menu. By default, that menu item having the one more option. One more product they will give. Yes or no? That is no need of break. By default, you have to purchase 2 Santosh soaps. You will get the pen by default. Okay, that means how many cases there? 2 cases. How many products there? Two products. One is the soap, another one is the pen. Okay, one is the soap, another one is the pen. That is the concept. Okay, without break, which case has selected? From that case, remaining all cases are also selected. Remaining all cases are also executed. After default, is there any need of break? After default, any need of break here?
No need, sir.
Because of no statements after default. You will write default at very starting also, no problem. Wherever you will write the default, it's not a problem. But here you will write it the default. You will write the break. That's why the default is written always lost. You have to avoid break statement. If default is at very last, okay, now after case 5, no need of break. After case 5, nothing is there. Which are the last, either cases or default, no need of break. Okay, no need of break. Not only here, the default, you have to use in the middle also. It's not a problem. Wherever you can write the default. This is the exact selection. Wherever, what's the problem? Okay, wherever it is, by default, okay, the case has selected. If no case has selected, default has selected. Okay, suppose for execution of default, how many equality relations has executed? How many times equality relation has executed? Suppose you can give the 6 instead of 1, 2, 3, 4, 5. How many times the equality relation has executed? This is the knowledge. How many times? ఎన్నిసార్లు ఎగ్జిక్యూట్ అవుతుంది ఈక్వాలిటీ రిలేషన్?
5 times.
5 times. 5 times. Case 1, that is 6 is equality 1, false. 6 is equality 2, false. Up to 6 is equality 5. All are false. By default, default has executed. By default, default has executed. That is the concept.